Good morning, scholars. So we're in Ocean, Atmospheres, and Climates, lesson 1.5. And so we are going to start off on Amplify today. So Amplify Science. And we are going to scroll down until we see Oceans, Atmospheres, and Climates. And we're going to go to Chapter 1, Lesson 1.5. So, we already completed 2 yesterday, so today we're going to do 1 our warm-up, 3 our student discussion where we're going to be evaluating evidence, and then 4 your homework. So, 1. You are going to be answering the question, why is Christchurch, New Zealand's air temperature cooler than usual during the El Nino years? So you're given 3 different claims. Claim 1, the amount of energy from the sun. Claim 2, something about the Earth's surface changes. Or claim 3, something about the air changes. You're going to choose whichever one you think is less convincing. And then you're going to rate your explanation here in the bottom. And then you're going to submit it and go to the next activity. So we've already done our right share. We did this with the Google form yesterday. So we're going to be moving forward. So we're going to check in here. So let's just do a quick review of our right share. So yesterday we reviewed why different locations have different air temperatures. With the question, why is the average air temperature of Makassar warmer than the average air temperature of Christchurch, right? And we should have gotten this example of an exemplar. The average air temperature of Makassar is warmer than the average air temperature of Christchurch because the average air temperature of Makassar is warmer than the average air temperature of Christchurch because Makassar is located closer to the equator than Christchurch, right? And we saw that in the image. Oh, Miss Jackson has to pull it up. Let's go back. We saw that in the image here. Makassar is about 4 degrees south, whereas Christchurch is somewhere in between 40 and 60 degrees south of the equator, right? So that would explain why Makassar is at 27.5 degrees Celsius, where Christchurch is at 11 degrees Celsius, because we know that the locations nearer to the equator receive more incoming energy from the sun. As you move away from the equator, the locations receive less incoming energy. So, and energy from the sun is transferred to the Earth's surface and then to the air, which means Makassar receives more energy from the sun than Christchurch receives. So if anybody needed an additional example, if anybody got confused yesterday, this is something to help you out so that you're on the same page as everybody today. So we received a new letter. So Carrie, right? She sent us a new letter. So now that we have learned about what determines the location's temperature, we're ready to begin helping us determine why Christchurch, New Zealand air temperature is cooler than usual in El Nino years. I'm sending evidence that might help you with the investigation. Please review the evidence carefully. Remember, your research will help farmers be better prepared to protect their crops and livestock for temperature changes in the future. Right? So the first graph that we're going to look at is average air temperature in New Zealand. And you guys will see it if you go to, right, we left number 2, we're in number 3. You guys will see it if you're in the first page of number 3. So you're not expected to annotate this graph. This one, Miss Jackson is going to annotate for you. So let's look at some of these things that we see with this graph. So first thing I notice is the title. So the title is telling me average air temperature in Christchurch, New Zealand, right? So I already know. Let me add a comment, and you guys would just be writing yours on Amplify, and I'll show you what that looks like in a second. But so I already know that I'm going to be looking at air temperatures, right? So I'm going to be looking at air temperature, and this is an average. So this is kind of what we see all year long, right? So I'm going to write over the year, right? Because an average, it takes the temperature over the year. So let's see what I'm looking at on my axis. So it tells me on my y-axis that it's degrees Celsius, and it's moving in increments of 2, 0, 2, 4, 6, 8, 10, 12, right? So I know that I'm looking at my temperatures, and I'm looking at 2 years. I'm looking at the normal year, and I'm looking at El Nino year. So let's talk about some things I'm noticing. Right, that during a normal year, the average air temperature is 1 degree higher than during El Nino year, right? And so this shows that we are comparing temperatures at two different times. So normal year was 12, and during El Nino year it's 11, right? So that's what this graph is showing me. We're going to be looking at three questions as we explore. So 1, what does each graph show? 2, what questions do we have about the graphs? And 3, how is this connected to what we learned about climate, energy, and temperature? So we know that this graph is showing us, and Ms. Jackson's just going to input another shape. Let's do another arrow this time. Let's get fancy and do a chevron. Let me delete that. So I know that this shows me that during a normal year, it is warmer, and I'm going to say 1 degree on average in an El Nino year. Notice how I went back and edited my work. So last but not least, I'm going to be making connections to what I know about energy, about temperature, and about climate. So I know that when the temperature is warmer, that means that it's getting more energy. So if it's colder during the El Nino years, what do you guys think? Yeah, that is getting less energy. So I'm going to put that in here too. So during El Nino years, Christchurch is getting less energy from the sun. Yeah, so we're gonna look at what's going on, right? But that's a connection that I can make, right? And I'm gonna even put in even more, because we know the temperature is measured from the transfer of energy from the sun to the Earth's surface to the air. Boom. So Ms. Jackson had a lot to say on this graph, and you may find that you have a lot to say about the graph, or you may not have a lot to say about the graph, but make sure you're hitting on all three questions, which is, what does each graph show? What questions may you have? So if you have a question, you should have at least one. If you don't have any answer to the third question, which is how the evidence connects to what we learned about climate, temperature, and energy. So now that we've wrapped up this first graph together, you guys are going to go to number 2, and you are going to be answering these questions. So, right, why are they different? Why is it different? Places have different temperatures. Okay, so, right, you can click on it and add any annotations you want. So if you see, Scala already added one. If I want to add another one, right, I can say this is showing me that it has the same amount of energy from the sun. Wow, so I'm seeing that the same amount of energy is transferring. So what's happening? So I see that the same amount of energy is being transferred from the sun. So if the same amount of energy is being transferred, then what could be happening, guys? Since we know the temperature is usually dependent on the amount of energy transferred from the sun, we have to see what is happening, because the Earth, this means that the Earth is getting the same amount of energy. So what's different? So you guys are going to explore that with the next few graphs, right? Notice that this is a normal year, this is a new year, and this is telling us energy from the sun. Okay, and if I look, those look about the same, right? Oh, that one looks a little bit less, but still something might be happening. So I want you guys to explore that. Okay, and then last but not least, you are going to self-assess. So we've been doing some work for the last couple of weeks on this, and I just want to know, where do you think you stand, honestly? So you're going to tell me if you understand how energy is transferred to the air of New Zealand, right? You're going to tell me if you understand what's happening to the amount of energy in Christ the Church. You're going to tell me if you understand how the distance from the equator affects the air temperature. Right? You're going to answer all these questions. You're going to let me know what you know and what you don't know, so that I can help you. All right. So that's it for today. See you tomorrow.